So in this video, I would like to show you what you can find in the Analysis tab. So this tab is not really required in order to pattern with the NanoFraser. So we could just stop at the session, but to have more information regarding our patterning, our corrections, we can open this Analysis tab, and I will just quickly show you what you can find here. So first of all, we have the first live diagnostic. We can see the forces. We can see the depth-wise right forces and the pixel-wise right forces. So for example, how much force we are applying for each pixel. Here we see that we are live patterning a sine wave. So we expect also the force to have a sine wave behavior. We are patterning with a Kalman feedback, and we have a set of corrections such as the thermal conductance corrections, the fast scan correction, slow scan correction, and also bowing correction. And these corrections are also shown in this sub-tab. So for example, you can see the Z drift, correction. In this case, we don't see any anomalies in the Z height, so we assume that the tip didn't accumulate any contamination or didn't have any sort of blunting, but these events usually can be seen from the Z height, and this is I'm just showing you what you can find here. Then if you want more information regarding this specific analysis tabs, you can also consult the user manual. We can also see the depth feedback for the Kalman, so we can have also an idea of the evolution of the parameters that give us an indication of the convergence of the feedback. So in this case, at around minus 4.5, we have the convergence of the Kalman feedback. Minus 4.5 is around here. So initially we have an adjustment of the forces, and then we converge at around here. We also have the bowing correction and the bowing prediction. In this case, we are only using the bowing correction. You can see that the bowing correction is applying some voltage at the edge of our fields, which is a typical case for the bowing correction application. In this case, we were able to pattern well, so the bowing correction probably is helping us in achieving a better pattern. For the bowing prediction, you also need to activate the bowing prediction in the feedback parameters to see graph here. And you can also see the thermal conductance correction. In this case, was active, even though it's not really necessary for a case like ours where we are patterning on a silicon sample with just PPA on top, because we assume that the thermal conductance will not be a factor. But in case you're patterning on different materials for special, you have some more special substrates, then this correction can be quite helpful. So this is pretty much what you see in the live CLL diagnostic. In case you want to have an analysis of the TSPL, you can see the read-write offsets for X and Y. You can also change a little bit the right field opacity and estimate the offset here, and also do a in software read field flattening in case there are some artifacts in the topography that you read with the NanoFraser. You can do some flattening operation using these tools here. Lastly, if you perform stitching, so either you have active field stitching or standard stitching, you can analyze the stitching results. This can help in understanding better your patterning when you are splitting big geometries. So you see the stitching result, stitching offset analysis and the XY drift correction, which again, this is more can be definitely more helpful when performing a stitching of multiple fields. So this is pretty much a very quick overview of the analysis tab. Probably the most used subtabs in the analysis are the right forces, Z drift, bobbin correction, and thermal conductance when using standard TSPL operations, but sometimes you may also want to have a look at other features, especially when doing stitching, for example, or if you're interested in doing some better flattening of the topographies that we generate with our NanoFraser. So I hope this was helpful. Again, you can find more in detail information for each subtab in the user manual, just pressing the question mark in each section.